Yeah, so like when you're trying to make it, where you set the like size and whenever you change your window size will adapt. Yeah. When I get all my so where's this is supposed to be separate. For some reason, it's going to go under That's what it was.
Like somebody's exploring their Zoom capabilities. Good job.
So I don't have these. These are done for these are oversized for HTML. I could almost work with these. Like I would do would always be up here, or up here. They could text to the dashboard. So I found a way. I found a video to show you that it puts both
Interesting group. How's everybody today? Make sure you're in the Zoom session, like I said in that announcement. Make sure you looked at that announcement on Discord. But I will be taking attendance just from the Zoom session. So whether you're in class or not, I need you in there. That'll hopefully reduce some of the delay in us getting started every time. Since we've been having to do all that attendance. We're getting to the bitter end, aren't we? See a lot of you here today. I hope you guys had a good break. Everybody has fun. I didn't get to see my kids, you know. So that's a bummer. I don't like it. I like to be able to see them. So I don't deal well with people who traveled a lot. That's why I keep saying, if you traveled, make sure you stay home because you're germy. We don't want it here, being out there in the millions of people that have traveled. Because, yeah, I sure would never tell my kids to not come unless I thought it was really important. All right, so I went ahead and deleted the Colab notebook assignment in Canvas because people were getting really stressed about it because it shows a due date of today. And versus answering a bunch of questions and things about it, I just deleted it. when we left off last time before Thanksgiving, I told you I would get you a video or something about it. We would figure out what to do. Well, I wasn't able to do that with all of the requirements that administration put on us for making decisions about what to do with COVID, whether we were going to be in class or not in class, and planning and all sorts of things were required. So you guys fell down in priorities and you did not get a video. So I just deleted that assignment to keep people from worrying about it, hopefully, because everybody was really stressing about it. So we need to regroup and figure out how we're going to handle things moving forward. Not a problem for you guys. We actually have today, Wednesday. Next week we meet 2 times. And then that last week of finals, we meet on Monday. Monday is actually class day that week. So we have plenty of time. So you guys are golden. The other class, unfortunately, that hybrid, you know, that we're trying, they meet one more time after this week and that's it. So we're kind of in a little bit different of a situation. So if I seem stressed, it's because of them. We have plenty of time in here. So I don't know what that means, but that's just the truth of where things are. So with our collab notebook, I don't have that assignment activated again yet. I'll turn it back on. Somebody's check marked it for us. Good reading of the Zoom stuff. We want to use those tools. But I'll turn it back on when we're ready and we know what the due date should be, because I don't know that it should really be due tonight. So I'll re-enable it based on how far we get through it today and things like that, because I would like for us to do a little bit more exploration of arrays instead of just shoving that thing up there and saying we're done with it. This week, though, we're really going to be looking at doing some file processing. This is one of those things here at the end of the semester where it's an objective for our course, but I've been checking in, you know, on some others and asking students, have you guys done functions yet in your class? Have you guys done arrays yet in your class? And I can tell you that you guys are, I don't know, do you want to hear this? Yeah, you're fur ahead, you're fur ahead. So sometimes that's painful because you've had to work so hard to get to this point, but in the long run, it's worth it because that means that you are going to understand some of the concepts moving forward in your classes, hopefully, that you won't have to struggle with as much. Now, because of that, I felt like we had time to look at arrays a little bit more. So in the file processing stuff, this is an objective that some of the classes won't get to at all. We're just going to talk about it. We're going to do a couple examples of working with some different files. And then we might have a little bit of file processing in our final, hands-on final. But what I really wanted to spend time with is looking at glitching an image, because I think it's really fun. And when we're glitching an image, we're going to take a picture and we're going to use that image picture as an array, right? Because it's a bunch of rows and columns of pixels. And then we're going to scan through those rows and columns and change some of the colors so that we can change the way that image looks in our output. So that'll be our last assignment that we'll have. So it'll just be this collab notebook and that glitch and image, and then our final. So we're getting towards the end here. Okay. I wanted to show you this site. I think it's new, and a student in the hybrid class obviously used it a little bit for some training. So this looks to be a really good site if you want to try some practice projects. And they have some code examples and things like that. Like I say, it's very new. As you look through it, I found pages that weren't completely developed or things didn't quite match the instructions. So there's a little bit of that going on because it is new, but that means that you have an opportunity to influence them in their building of it because you could send emails and things like that. But if I look at Python Home, here of this site, it just starts out with a Python tutorial. So that's really good. It has some good stuff. But over here on the left, it also has links to just specific topics. So if there's an area of something that you feel like you could use a little practice on, you can go investigate that topic. One thing that I thought was really interesting is that they have some really good date and time information. And if you've noticed, that's something that a lot of the beginning programming classes tend to kind of avoid, because working with dates and times can be a little bit messy. So it's nice that there's some examples out here for that, because that's something that we do have to do. They just like to leave it out because it can, like I said, get a little bit ugly. So this is a great site. It is w3resource.com, and then their main page has links to all sorts of different languages and tutorials. The Python tutorial is here under backend tutorials. So in the miscellaneous tutorials, there's a link to Python projects. And that's a great place where if you just want some different projects. So this one says it has 11 projects with the solutions. So you can kind of challenge yourself, see if you can work through the projects on your own. But then if you run into trouble, you've got a solution, so you can refer to that. It's a very neat site, I think. Always interested in any feedback that you have about it. So if you run into any trouble or anything, let me know. All righty. Padlet, okay. You guys did a good job on that, and I let it slide. Get back to our module so I can find that thing. It was way back because we were working with repetition. So it's in week 10. If you want to find that link to the Padlet code snippets thing, but I'll bring it up here so that we can get to it, hopefully. Now for each of these, we can enter the code and test it. That would be a good thing. I have the solutions. Hang on, I didn't get it open like I should have. And it's in a OneNote document, so I have to be careful. Got almost everybody here. Pretty close. I can hear somebody. I don't know if my presentation is even going to match. We're just going to have to look at them. What a mess. This is why I've avoided our Padlet thing. All right. So what's going to happen with this one? Take a look at it for a second. Don't look at the answers. Oh, we have some good answers, and everybody looks really good. It says the statement gets printed indefinitely, with X in the statement increasing every time. So this one is an infinite loop, right? And it does some of that Python formatting that uses the percent type formatting, which can be so ugly to look at. So it's good practice in both ways. So we're going to see a message that says, to infinity and beyond, we're getting closer on 1 now, on 2 now, on 3 now. So do make sure you understand the fact that as X's value changes, the placement parameter here is going to be replaced by that value of X. So we'll see that value updating in the print statement each time that loop is executed. So again, if you want to run that one in Python, you could try that and see how it works and make sure that you're gaining clarity on that. So good job, everybody seemed like they understood that that was going to be an infinite loop. The infinity and beyond kind of helped. What about this one? Take a look. We we have some good answers. Again, it will go through and print each character of hello world on a new line. So we're going to get the H, and then the E, and the L, and the L. And that's because this was a little early on, because when you guys did this, we were just beginning with loops and if statements. But because the string is considered an array of characters, this string variable is actually an array. So when we use the for loop, we're saying that I want to see each entry in this array as a variable named X. So then each entry in the array can be processed as X. So that's why we see each letter printing out. Very good. This one, is it the same? Should be, right? So this time, instead of just seeing the letter, we're going to see current letter, colon, and then the letter. So current letter P, current letter Y. And again, that's because a string is considered an array of characters. So we can use the for loop to handle it like it's a collection. So good job. Now this one, the loop would print we are on time followed by the number 0 through 2 on a new line, okay? Prints we're on time and uses the numbers in the range, we're on time. Good, everybody's got a really good description of that. So again, the replacement parameter %d is going to be replaced with the value of the X variable. So as we process that loop, we're going to see we are on time 0, we are on time 1, we are on time 2. Are we going to see we are on time 3? All right. What about this one? We're going to print, let's see, the first time, I is going to be 4, right? So the while loop is going to be true. So I'm going to execute that code. So I'm going to print out the value of I, which is 4. Then I'm going to add 2 to I. So now I is going to be equal to 6. Is it still less than 9? Yes. So I'm going to print it. Now I'm going to add 2 to it. So it's going to become 8. In the while loop, I say is I less than 9? It still is. So I would get an 8. Then I'm going to add 2 to I. So now it's 10. Is I less than 9? No. So that'll be the output from our loop, 4, 6, and 8. And I think everybody's got it. Now on this one, with your responses using Padlet, I know it's not as specific, but we are specific programmers. So we want real specific answers. Like it will print 4 on one line, 6 on one line, 8. And of course with Padlet, you guys just did a great job coming up with those kinds of things. But yes, us programmers are specific. I love that when I first started working here and Dr. Ford gave me this thing, this awful thing, and I've tried to get away from it. You guys won't have to use it. But it was a tool to auto-grade students, and we still do use a lot of them because sometimes it's the best way to get grades back to you guys is with the auto-grade tools. But it's called Hypergrade, and it was super, super specific. So if you did a \n to go to a new line, it would know that that was a \n versus using a print statement to go to a new line. It was so specific that it could tell the difference. Just drove people crazy. And I always was surprised at the beginning of C#1 when I get these emails from people saying, this is so detailed, this is ridiculous. And it's like, that's what you're getting into, you know? I mean, that's what we do. We are that detailed. Yes, we are. When I first started working at Conoco, one of my first assignments was to type in like 15 people's social security numbers. That doesn't seem like a big deal, right? But the next day when I got done, my supervisor came in and she was like, that was so great. You didn't make one single mistake. I checked because those social security numbers were like the CEO, the CIO, the top people in the company, because they were running a report on the top salaries. And so all of those numbers were very, very important. So had I made a little mistake, it wouldn't have been the end of the world, but she definitely wouldn't have trusted me like she did moving forward. So those little detail things are really important for us in our field. Okay, what about this one? The smartboard looks really bad. So I'm gonna look, I hope you can see it better on Zoom. We start out with temperature equal 115. I'll write that down, do some desk checking. For those of you that are at home, I'm gonna put it up here on the board. I'll turn it on and maybe you can see it. No, can't really see back there very good. Hang on, I brought this thing, let's try it. Probably. Need a Wi-Fi connection. Let's see if I have one. Probably not. Well, it's just one of those things we'll have to walk through on our own in class. So we start with our temperature equal 115, and our while statement says while it's greater than 112. Well, it is, so we're going to print out the temperature. So I'm going to print out 115. Then I want to subtract 1. So now my temperature is 114. Go back to that while statement. Is it still greater than 112? Yep. So I'm going to print it out again and subtract 1. So now it's 113. Is it still greater than 112? Yep. So I'm going to print out 113, subtract 1. So now it's 112. Is it still greater than 112? Nope. So I'm going to print at the end, the T is cool enough. So this is one area where, if you remember, I told you that this activity, if we weren't COVID-y, I would do with giant Post-it notes, and you guys would Post-it note, and we would have that same day been able to grade them. And that's where a lot of people would groan, because they would get it wrong because they forgot that final message. So the T is cool enough. Don't forget those after the loop things. What's this one gonna do? Our variable here is going to be x. And we start out with a for loop saying, I want to use x in a range up to 10. So if I do that, what's the first value that's going to be assigned to x? 0. So then in our code, we're saying if x mod 2 equals 0, remember the modulus command does a divide and returns the remainder. So we're saying, is the remainder of x divided by 2 equal to 0? For 0, it would be x. There would be no remainder. So in that case, we would continue, which means we would go back to the for loop to evaluate it again. All right, so for 0, we would have nothing happen. When we went back to our for loop to evaluate again, Python would change our x value to 1. Now, in our if statement, we say if x modulus 2 equals 0, would that be a true statement if x is valued at 1? No, exactly. We would have a remainder. So we would fall through, not do the continue, and instead we would print the value of 1. Now we're going to go back to our for statement. Python is going to change the value of x to 2. We're going to hit our if statement. If x modulus 2 equals 0, it does. 2 divided by 2 gives us no remainder. So we would continue. Python would change the value of x to 3. We would try a modulus command again. Our if statement would be false because we would get a remainder value of 1. So we would print out x. Python would add 1 to x. We would use the modulus command in our if statement with the result of true, because 4 divided by 2 gives us no remainder. So we would continue, go back to our for loop where x would be set to 5. When we do the modulus command, we'll get a false. So we would print 5. So we can see now the pattern, right? We're printing all of the odd numbers. So the next one would be 7 and then 9. Now we would have to reevaluate again, looking at our for loop. When x becomes 10, would we execute the for loop again? No, because we've reached our limit. So we would end up with our output of the odd numbers between 0 and 10. I lost it. Here we've got this one. In this one, we're saying that we want to print out x while it's less than 3. So we would print 0, 1, and 2. But then it has this weird else clause where we print out this statement, final x equals whatever. And then as we go through, everybody's pretty sure here, it says that it's going to print final x equal 2. So it looks like everybody's got a really good understanding that went through there. We are going to run the body of the for loop for each value in our range, 0, 1, and 2. Then when we exceed our range, the else clause will be executed. So the else clause would be executed like either way if we could never execute our loop body and when our loop body execution is done. So good job. Sorry it took us so long to get back to those. We will get on them though. All right. Just lots for us to do. So let's look at our chapter 7 colab. The one I put out here, can you solve student activity 4? That's where we left off. And so we probably have some people that have turned this in and figured it all out. But I really planned on us working on it together. So if you're one of those awesome people, please expand its capabilities so that you can keep yourself working and finding out great ways to do things. Otherwise, let's try and do this one together. Now, as we look at it, I keep saying things like, don't try to convert the pseudocode to Python. And sometimes I want to just throw the pseudocode out. That's what our textbook has. And so I want you to have a reference, something to look at. But if we look at our pseudocode and we kind of think of it as a design document instead of code, let's review what this 7.4 example is supposed to do. The heading says, arrays save you time and effort. So it doesn't really tell us much about what this script is meant to do. If I look at the pseudocode, it looks to me like I'm setting up an array with 100 entries of some sort of float value. I'm going to be doing some sort of sum, and I'm going to be counting how many entries are entered probably. So my first prompt is going to say enter a test score, and I'm going to give them a value of 999 to quit. And then I'm going to read that score, and if the score is a good one, then I'm going to add it to this medieval array. I'm going to add to a counter to show that we had a new score, and I'm going to add this score to a sum. Then I'm going to prompt the user to ask them if they want to add another one. And I want to do that last in my loop so that if they type in 999, it'll end the loop. Notice how by doing it that way, I don't have to have any break statements or anything like that in my code. So I could summarize and say, I want to create an array of scores that are float values, and I want to prompt the user for the scores, summing them and counting them. When the user is done entering scores, they'll tell me that by typing in 999. I'm going to calculate the average. And then I'm going to go through the array. In line 16, a new while loop starts. And I've set up a new counter here. And while that counter is less than however many entries there were, I'm going to be I'm going to be checking each of the entries to see if they were greater than the average. I'm just going to count how many there were that were greater than the average score. So let's see if we can do that without trying to convert from pseudocode to Python. I'll zoom in just a little bit. Oh, let me fix it. Do you have the colab document? Okay, that's what I needed to know. Because since I got mad at it and just deleted it, you can't see it. So let me fix that. Okay, refresh and you should see it, sorry. If anybody else is missing that, you should be able to see it in Canvas now, that link. Okay, so looking at this one, we're at example 7.4. Arrays, they move time and effort. So in this one, what we could say, I guess, we'll use an array to store scores, calc an average, and find entries that are greater than the average. For our example, we need some variables. And we've seen a lot of different ways that we can use arrays with Python. I'm trying to spell medieval right, I'll spell it wrong. I before E. Now, in our example, they give it about 100 entries. At this point, I'm just going to say, hey, Python, it's a blank array. So tell Python this is an empty list. Array. We have a sum and a count, and they want it to be count 1 because we're going to use this other counter named K, and we wouldn't want them to get confused. So we'll make it count 1. Now in our program, the first thing we want to do is prompt for a test score. And they put that test score into a variable named score. We want it to be a float. So I'll cast it as a float and enter a test score or 999 to exit. And then in our loop, we can start up our loop by saying, while our score is not equal to 999, as soon as it is, we want to end that loop because they're done entering entries. And we saw before Thanksgiving, if you look back at some of these examples that we did earlier, we used the kind of syntax where we use the square brackets and a counter to keep track of which entry we were adding to the array. Well, we could do that this way right now, but I wanted to make sure we had an example that used a more Pythonic way of doing it. So we're going to say, hey, medieval array, I want you to append the score. And this just adds the score to the list or array. Now, what else do we need to do with that score? We needed to add it to our sum. Sum plus equal score. And then we want to add to count one a value of 1. And finally, we want to ask for another one. And that way, we're putting this at the end of our loop so that we can end our loop if they type in 999. When we do things this way, when we read before the loop begins, that's a priming read. And they call it a priming read because they're relating it back to an old school pump. They call it priming the pump. And with an old school pump, back in the olden days, when they went out to use their pump, they couldn't just start using it. They actually had to keep water, keep some leftover water to pour into the pump to prime it to get it started. So that they have all sorts of little sayings that have to do with that because, you know, if people weren't good enough at saving their water to keep enough water to prime the pump, then they had a whole bunch of problems. But anyways, they say this is like priming the pump. We're asking the user the very first thing to enter a score, and then we're going to go into our loop using that pump's data, and then we're going to keep that pump going to ask for another at the end of our loop. So notice how if we did any more work after asking for another, we would be messing up our logic. We need to make sure all the work has happened before we ask for another input. So it has to be right before our loop starts and at the very end of our loop. All right, so that got us all of the scores they want. So now we know that we can calculate our average, which is a new variable, by taking our sum and dividing it by that count. Everybody doing okay? Doing okay, doing okay. All right, so now we've got our average. We should run this thing. I don't want to keep adding to it. What if there's something wrong? I want to see if it breaks before I go any further. So I'm going to make sure that I don't have any errors and that I can type in some data. 21.5 or 12.5. And I'm being able to use decimal places. Now remember, at this point, it will crash if I type something in that's not numeric. I don't have any code in there to handle that. So I'll type my 999 to make sure that it stops the loop. Looks like everything's good there. Anybody have any problems? Did it work okay? Ready to keep going? Good. All right, so we've got our average calculated. Now we would like to loop through our array to check each entry to see if it is greater than the average.
Sorry, this is kind of late, but mine doesn't quit when I put in 999.
Oh, okay, can you share?
Yeah.
Not a problem, sometimes you can't even tell. So look at the end of your while loop. What's that variable name?
Oh,
Do you see it? You can handle that one. And so that's one of those things with Python, you know, we've been defining our variables at the top so that we are following those good programming practices, but we know we don't have to. Well, that means we can have errors because if there's a typo, we can have it be using two variables when we think it's just one. So beautiful. That looks good. Thank you. That's a real common problem that we have with Python because it is so flexible that way. All right, so now we're ready to loop through our array, and I want to look back at their example. They use a while loop, and they say, as long as we've got something, you know, as long as this new K counter is less than our original counter. Okay, let's do it the same way then. K equals count 1. While, oh, nope, sorry, K is 0. I was like, that's not right. So then while K is less than count 1. So count 1 is going to be our limit. That's how many scores we have. We're going to check our score. If this score at array entry K is greater than the average, we want to add 1 to K. That's all. So we don't really need to do anything else. That's not right. What am I doing wrong? K equals. Oh, look, there's a count 2. I thought they were using K because they've got an error in the pseudocode, don't they? So in their pseudocode, or I'm doing it incorrectly, because to me, I was thinking, oh, K must be the count of how many are over our average, but they're actually using count 2 as the count of how many are over our average, and they're using K to keep track of where we are in the loop. So notice how all these different variables can be interesting to follow. So let's put some documentation here. K equals 0. K will be our loop counter. This will be used as our loop counter. And then count 2, they also set at 0, and count 2 will be used as the number of scores that are greater than the average. So sometimes we like to not put too many comments in our code because we don't want to be too distracting, but sometimes it can be a really good documentation practice just to kind of identify anomalies like this. So I do want to add to K, but I want to do that outside of the if. So I'm going to backspace that. Inside the if this one is bigger than the average, then it's count 2 that I want to add to. And since we're just adding 1 to all these different things, it can be quite confusing. So I'm going to put a comment here on adding to count 2. We found one that is greater than the average. Now all we need to do is print everything out. They want us to print out the average is and the number of scores above the average is. So let's do that. I want to end my loops and my if statements. So I'm going to backspace and make sure I'm all the way back in column 1. And I want to print out the average score is our average. And then I'm going to print the number above average is. And this was our count 2. So we're going to convert each of those to a string and print them out. So I want to try running this. And I'm just going to do, I guess I better do at least 3 so I can get a reasonable average. I'll do 50, 60, and 70. And then end it. So I should see an average of 60 with 1 score. Oops, I should not see that. Score, it says float object is not subscriptable. Well, I see what I did. I don't want the score variable. I want the medieval variable here. I want my array, and I was talking while I was typing, and instead of using my array, I used my individual score that had been last entered. Wrong variable. Really common in programming, huh? So let's run it again. 50, 60, 70, 999. Oh, that looks better. The average score is 60, and the number above average is 1. Did everybody get something good there? Did it work? Did it work? How's everybody doing at home? Getting stuff? Thumbs up, thumbs down, something. All right, so we got some good numbers there. One thing that I'd like for you to do here real quick is I'd like to add a print statement and print out the maximum score. And if you do some Googling, You should be able to find a way to do that in Python without looking at every single score in the array. This while loop that we created, we looked at every single score in the array. But with Python, there should be a list function that allows you to find the greatest. So I'm going to give you a couple minutes to try to find that, and then you can lead us, the rest of us, forward with it. So I'm going to set my alarm for 5 minutes. Let's see what you can find. You should also be able to do the minimum at the same time if you find that information.
I have a issue on 7.4. It says on the bottom, float object not callable for print the averages plus string average.
Go ahead and share it. Was that the one where we need to use the array? Oh, no, it's different. That's the line.
Yeah.
That's canceling. I guess let's run it again. Let me see what it's doing. It's like it didn't calculate your average. Change the plus to a comma in the print statement. And let's try it again and see if that, I don't think that's going to matter. I just want to make sure. There's a typo somewhere I don't see. I just don't see it. Everybody, can you guys look at the screen and see if you can tell what's wrong? I don't see the problem here. It's got the print statement, and it's canceling when it's trying to print out the average. I don't see it.
It's going to be the second parentheses at the end of the print statement.
Well, it doesn't really matter. Not that.
Yeah. I'm not seeing it. I just wonder if it's something to do with those comments. Let's get rid of that comment right before you calculate the average on the line above. It shouldn't matter, but sometimes Python just does weird things because of stuff like that. No? I just don't see it. If you comment out that print statement, does the next print statement work?
What?
If you comment out the print statement that's canceling, does the next one work? Just put a pound sign at the beginning of it.
Oh, I know what it is. He doesn't have the count2 variable on the second while loop.
Do what?
The count2 variable, he has set it as count1.
Yeah.
That could be it.
Yeah, it should be count one.
Yeah, that's about to say.
You were good. I was like, I'm not seeing it. It's like it thinks print is something different. There isn't. It's like it thinks print is not the print function. But it knows it is because it's yellow. Comment out your other print too so that you can do some of these max things with us and we'll figure out what's going on with it. It's just being evil. All right, who's got a max and min to show us? Let's see him. Let's see him. Yeah, take over. We'll, Colin, go ahead and release that and we'll make sure that we'll take a look at our minimum and maximum. Just there where your share screen is. You should see stop share there on your Zoom toolbar.
Well, I hid it for like maybe.
Did you hide it?
Yeah.
And it's effectively hidden, huh? Let me see if I can stop yours. And then let me stop my share. Did it make your toolbar show back up though? Because I'm not sure how to get it back if it's hidden. Austin's got some good stuff though for us he found. What did you find? Ah, very good.
I found a list function that you could use, but it's the exact same as the array. So I just use max and min for finding your maximum in that set that you create.
So for max and min, these are array functions. So we have to put the name of the list in the parentheses as a parameter for those functions. So notice how that's a little bit different. We have medieval.append on line 14, where we're using an array function, and we have to specify the name of the array, followed by the dot, and then the function, and then we're passing in as a parameter the value we want to append. And then down in line 33, we're using an array function max, but notice that the array name does not come before the max function. The max function is static. It does not need the array name at the beginning. It needs the array name passed as a parameter so that it can work on the entire array. So we'll see some differences in coding depending on how that function is set up within Python.
Yeah, I saw a few different ways.
Yeah, and so we could see different ways of doing it. Just lots of different standards. So we can just try different things, but it's basically depending on whether the function is going to process one entry or search the entire array. So looks great. Thank you. Everybody got that? See how we can use some of those list functions in Python to make things easier. And usually when we're doing code, we're going to go ahead and use the more difficult way of doing things just so that you get a chance to see that logic, because it's always a little bit simpler to use those built-in functions that give us those capabilities. Okay, example 7.5 is really similar. In 7.5, we want people to enter a name. So you can kind of think about this one as the same as the sibling names, I guess, that we did several weeks ago, where we asked someone for their sibling's name, and then we just printed it out because we didn't have any way to save all of the siblings that they gave us. We just input one and spit it right back out. Well, now we have more power. So now we know how to read that name in and save it in a list, in an array, and then we can print out all of the names all at once. So let's modify our sibling list to be that way. So I want to go through the pseudocode because I want you to try to work on this one on your own, and then we'll regroup to see how everybody did and make sure we've got it, because it should be super similar to our test scores, except it's working with strings. So we're going to set up a counter in a names array. We're going to prompt to enter a name, and we're going to ask for a star to be the indicator to exit our loop. We're going to hold the user's input in a variable named temp name, and as long as that temp name is not the star, we are going to add the name into our array, increase our account, and add for the next name. After we've got all the names collected in our list, we're going to use a k variable to be set as the size of our list, count -1. And then we're going to write out the names in our array from the last name to the first name. So in reverse sequence, that's why we're subtracting from k as we go. So we're going to write them out backwards. Okay, so I'm going to set my alarm for about 10 minutes and then see how everybody's doing at that point. And you are welcome to work with those around you, it's fine. Okay, I see a lot of people didn't even need that 5 minutes. Good job. Here's what I did. I'll let you look and compare your code. I bet it's fairly similar. See if there's anything that you're missing. The first thing I did, of course, by accident when I entered it, I left out line 14 here to prompt for a new name. And of course, if we leave that out, everything just sort of hangs, right? It just kind of waits. I'll show you what it does. If I don't prompt for that input again, I ask for the first name, I type it in, and then I think the computer is obviously broken. It's obviously not a problem with my code. Usually that's not what you should think. So usually if your brain starts thinking that, you should say, wait, chances are it's probably the code that I just created and not the computer that I've been using every day for months. So I'm going to check my code, realize I didn't do another input, and put that in. Now, speaking of that, everybody, all you awesome students, we are 2.5, 3 weeks from the end of the semester. My computer at home has 8 gig of RAM. Upgrading RAM is super easy, right? Is that something I should do right now when there's 2.5 weeks left in the semester? Exactly. No, it is not. I should hang on to that cheap Black Friday RAM until I go on break, and then I can do that upgrade. But right now, at the end of the semester, just like you, I need that computer to be working. So I should not do even the most minor of upgrades that would possibly wreck my ability to finish up the semester with a working computer. So every time I get an email saying my computer's broken, what do I think? It would have been wise of you to wait to upgrade your computer until the semester were done. You should start learning those things. These are important things for us to think about, right? We're computer people. If we have a big project coming up at work and we're really, really critical and we're like 2 weeks away from it, again, it would be a really bad time to upgrade our computer or to upgrade the computer at work, right? Now, sometimes we get forced into those situations because we can't finish up the project without the upgrade. But right now, we're not in that situation. So always remember, your computer is really important to you right now. It's not a good time to upgrade when you just have a couple weeks to wait until the semester's over, and then you can upgrade safely. Okay, does anybody have any problems with that program? We move on.
I'm doing the same thing.
Doing the same thing. You should restart that computer. That would be my other bit of advice for some silly problem. I hate going to, oh, you should restart it. But sometimes there's a reason they always say that. Okay, here's another one. Stringing arrays together. We're just going to look at that pseudocode. I think you guys have a pretty good concept of this. We shouldn't have to write this code. Because they sort of lost track on what they wanted to do there. So this one's important. Let's go to 7.7. In 7.7, we're finally going to see how we can figure out how many entries are in that array without having a counter. You know, so far we've been having to count how many entries we put into our list to know how many entries it has. But we saw that len function earlier that would tell us the length of a string. And we know now that a string is just an array or a list of characters. So could we use that len function to find out how many entries we have in an array? We could. So let's do that for this one here. Let's wait and see if your computer.
Oh, you won't have to. But
Yes. And it'll take you a second to get back into everything. We're okay. He's always super speedy. All right, well, he's getting that computer restarted. We'll see if that'll help. Because with Google Colab, you know, it's more understandable with Python on the actual computer that something could go wrong with it. With Colab, I am not as familiar. So we might have to do some investigating. One thing about Colab, though, we could easily switch to a different computer and see. But let's take a look at the pseudocode for 7.7 and we're going to take the pseudocode and kind of deconstruct it to come up with our requirements. So here we have an array that is keeping track of usernames, and we have a variable named valid. So we're wanting people to enter their usernames. Looking at this prompt here, we're asking them for a username that's 1 character but no more than 12. And then we're checking to see the length of that username to decide if it was valid or not lengthwise. If not, we'll complain to them. And if it is, we'll say it's a good username. So it seems like this one isn't using an array very much, but since we remember that a string is an array, it really is. So let's put some comments here. Colin's back in the Zoom session. Let's see how your Colab thing goes.
I had that happen one time, and I had to make a whole new colab document.
The whole new Colab document for it? Let's come along with us on this one, and we'll try it on a different machine, but I think that if it gets corrupted like that, we might be in some sort of trouble. It's obviously like it got to do with the import of the Python information into the Colab notebook. Nothing you did, I'm sure. We're just going to run into weird problems like that. Okay, so our purpose is going to be to validate a username by length. Now in this application, at the beginning of the pseudocode, they actually declare the username as a list or an array, and we don't really need to do that. We'll go ahead and declare username equal a list, even though we don't need to. And then let's say our valid is going to be equal to 0. 0 is going to be an invalid number, and we want to start out with something that's invalid. Now we want to get a username. But we're going to have to use the append in Python. So I'm going to tell Python to append whatever gets returned from the input statement. Let me get down here a little bit. Try to put everything inside of everything else. Now our input statement, we're going to say, enter your username. It must be greater than 1 and less than 12 characters. Kind of long. So I'm using the input function. I'm passing the input function this parameter, what the prompt is. Whatever the input function returns, which is what our user types, we're going to append to our username list. So we're just putting it all together, wrapping one function within another. Now, in their example, they say we're going to use our valid variable to equal the length of our user name. Then if our valid is greater than 0, do we want it less than 12 or less than or equal to?
Less than, or no, wait. Less
Oh, they're doing it backwards. Okay, so our first while, I've got an if and I need to make that a while. They want a while loop that continues while it is not valid. So while our valid is less than 0 or greater than 12, we want to keep asking. The way that Python works, we're just not going to be able to say that username is a list. So I'm going to say username equals an empty string. So change your username specification that way, or else we're just going to keep adding more entries to this list. It just works a little bit different. That's okay, we can handle it. Now, for our while loop, if it is not valid, we want to spit out some messages. Let me do a snip on this so I don't have to keep scrolling back and forth. Grab it. Okay, so while it's not valid, if our valid is less than 1, we want to print out a message. Username must contain at least 1 character. Please try again. Then elif valid greater than 12, it's way too long. We want to print username cannot be more than 12 characters. Please try again. And then in our input statement, instead of saying username.append, let's say username equals. Then I need to get rid of the outer parentheses because I changed that from being embedded as a parameter to just calling the input function and saving that return value. Now, once you have line 10 corrected, let's copy it. And I want to paste it within the while loop, but not within the if statement. So notice exactly where that's lined up. Should be indented under your while, but not under your if or elif. That should be all. Let's run it. Now I'm going to try an empty username first. And it just didn't do anything. Let me run that again. Let's try a really long one. This is really long. Oh, now that one worked. I got username cannot be more than 12. Please try again. So my problem is that I can't really make it, I guess, I can't really make it less than 0. And if I look at my if statements, there's something wrong there. Let me stop this. I see right away that in my while I say less than 0, but in my if I say less than 1. Seems like those should be the same since I'm testing for the same invalid condition. So that could be the cause of my bug. I'm going to change that to 1. Now let's see if I can enter that empty one and get it to give me the error. There we go, that looks better. So now I'm getting the error if I enter nothing, which is really the only way I can enter less than 1 character. And if I enter a really long username, I'm still getting the error. So let's try a valid one. And then it should end. Oops. 1, 2, 3, 4, 5. It doesn't seem to be updating my valid. Now, how could I get out of this loop? I can click the stop button for the colab document because that stops it. Another thing I can do is Control C. So anytime you're stuck in something like this, you can use Control C to get out. Of course, it's not going to do it in colab, so I'll use the stop button. So Control C if you weren't in colab. So what could be wrong? Before I go into this loop, I'm setting the valid variable equal to the length of the username. Then within the loop, I'm getting a new username. Should maybe this line of code be inside our while loop? Would that take care of our problem? Because if we changed our valid every time we went into our while loop, then it would get updated properly. So I'm going to cut this. Oops, not that much. Ah. I hate it when I do that. Control MZ, it's just totally gotten rid of my code altogether. All right, so I want my valid. I'm obviously selecting more than I think. How about I just use keystrokes, Control Z, Control X, and Control V. Really made that hard there to move that one line. I feel like I'm on Linux using VI or something. All right, so now I am updating my valid variable as part of my loop. Is that going to fix that bug? No? Really? On when valid.
If you enter one valid one once, it'll say it's wrong, but then you enter another valid one right, it'll finish it. It's weird.
It's really weird. Well, because we're not getting our valid set before our while. So let me undo that change. I guess we're going to have to do it in both places, aren't we? So since we're checking that valid variable based on our input, we'll have to update that valid variable every time we get input, which should be okay at the beginning of the loop. But if you see what happens, at that point, it's too late because we've already committed to running the rest of this loop body at that point. So we have to know what valid is before the while condition gets evaluated. So that's why we end up having to put that in both places. So really notice what the difference is in that, because it seems like at first it's putting it at the beginning of the loop should take care of all our problems. We're going to be doing it first thing in our loop, whether we're doing the loop the first time or repeating times, but it doesn't take care of our problems because we still have the rest of that loop body to contend with. So now we should be all fixed. Really long name, and then a valid one should just end it without that ongoing nonsense. All right, so that took care of it. So notice how rearranging things in your loop body should alter the execution of your loop if your loop is properly formed. So let me think of another way I could do this. What if I did something that I've seen here recently, while true, and then down here I said, if valid break. That would be bad code. Why would that be bad code? Because the break command alters the flow of execution. When I see a break command, that means to me that somebody didn't consider the full logic of the loop that they were implementing. It works. Sometimes it's the best, clearest way to do things, without a doubt. But in general, when you run into needing to add a break command, you should reevaluate your while condition. I should only see a while true loop in a game engine. I shouldn't see that in actual business logic, business code. Because when I see a while true, that means to me, this developer had absolutely no idea what kind of conditions they could encounter. And they just said, I don't care, just run this loop forever and I'll figure it out inside of there. Well, now that means I've got to figure it out way inside of there. I would like to be able to figure it out from the actual while loop code itself. So we want to try to stay away from those break statements, while true, things like that. In C#1, there's actually a module or two where I'll count off if people use break statements and stuff, because I want to break that break habit, because that's not a good way of handling things. Okay, is everybody working okay? Got it? Just printing? No. Can't do a darn thing to print. Okay, we just have one. What's this one? Oh, this one is like their first name, last name, and you actually did an exercise or a project that was just like that. So the last thing is some two-dimensional arrays. So I'd like to look at one. In this example, we're going to be looking at our student test scores a little bit more. And we have a need here to, besides keeping track of just scores, we'd like to keep track of several scores. So we'd like to have a two-dimensional array where we have rows and columns. So I would know that row 1 here were all the test scores for the student number 1, and row 2 here is all the test scores for student number 2, etc. But then I would also be able to look at it and know that everything in column 1 were test scores for test number 1, and everything in column 2 were test scores for test number 2. So I'm explaining this, but as you look at it, you're like, yeah, so it's just an Excel spreadsheet, right? And that's exactly what I want to create in my code, is I want to have this array that has that same format as an Excel spreadsheet of rows and columns where I can identify the individual items. Now, when I'm working on this, I'm going to be working with indexes again, because remember, when we're working with an array, an index always tells us what position we're in. Well, whenever I work with a two-dimensional array, I have to have 2 indexes, right? Because this is entry 1, comma 1. It's going backwards. I'll go backwards with it. Then this would be entry 1, comma 2, 1, comma 3. If I were column dominant, right? If I were column dominant, then the first number that I put in would be my column number. Now, if I'm row dominant, would be a little bit different, because I would say this is 1, 1. This is 2, 1, 3, 1. So different languages could use different dominances, right? This first index entry, is it the row or is it the column? Well, there are many languages that could do it however they want, but most of the time, you're going to see that we're row dominant. So we're going to say this first number is going to be the row number. So we would have 1, 1, 1, 2, 1, 3. This would be 2, 1, 2, 2, 3, 1. So if you can think about how those numbers, those index numbers would be assigned, it can help you find the information. Now, before we do this, going into two-dimensional arrays, some caveats. Kind of complicated, right? We don't use them very often because we have better facilities available. But as beginning programmers, you're like, well, I can't just be stuck with a one-dimensional array. I can use two-dimensional arrays, right? You sure can. And so I want to show you how you can do that. But I want you to also know that you're going to be learning other alternatives to using two-dimensional arrays so that we can make these things less complicated. So as we go through these ones, you know, remember, this is not the end-all be-all. It's a step along the way. So I've got my students and I've got my test scores, and I'd like to keep track of those things. And what they did in this example is that instead of just entering one number into the square brackets to say the size of the array, they put a comma and did that second number. So we're saying this array is 2 dimensions. It has 10 rows. Each row has 20 columns. So that's how we could read that definition. I want to skip down to 7.11 because it's the actual student one. So here we've got in our pseudocode, we want to enter some scores. We're going to have 30 rows with 5 test scores each. As we're going, we're going to have some variables, student and test, to hold some information for us. We're going to make sure that we don't exceed the number of allowable students. And then for each student, we're going to ask for 5 test scores. So let's see if we can create this thing ourselves. So this one, example 7.11. Two-dimensional array. So notice we're not keeping track of the student name in our two-dimensional array, just their test scores. And that's because in a lot of programming languages, we can only have data of one data type within an array. So our entire array would have to be float or integer or string. Python gives us a little bit more capability, but they want you to be aware that that's how things work in most situations. Now, our scores array is two-dimensional. So to specify that in Python, I do 2 of these, but I've got to double check. Let's double check. Python two-dimensional array. I can look at this tutorials.1, I think, but I don't know. Oh yeah, it works. Well, they've got all sorts of examples of how to allocate them empty or with data, but not how to allocate them empty. So we'll just have to hope that my memory is okay unless you guys can find it. If not, we'll figure it out as we go. We might have to figure it out next time if we run out of time, or give you the assignment to conquer it. All right, we want two variables, student and test, both as integers. Student equals 0, test equals 0. And then they use a for loop. So let's see if we can. For student in range, we want to start our student at 0 and end with 30 in our array. That's really a bunch. I don't really want to test that many, so I'm going to leave it at 3. I'll put a comment. Update end range to 31, because we don't want to test all those. Now, for each time we execute our loop, we're asking for a student. So we're going to say that we want to print out something to ask for a test score, and we'll save that test score in our test variable. So I'm going to change our input to an integer, and I want to have a prompt that says enter 5 test scores for student, and then they want to include, I'll put a comma, they want to include that student variables value +1. So it should say enter 5 test scores for student 1, enter 5 test scores for student 2. That's how they want that to come out.
Do we need string in front of the student +1?
Hmm?
Do we need string in front of student +1?
We don't have to because we use the comma, but if we use the plus, we would need to. Yep. Okay, so now they want us to force test scores to be entered. And so we're going to use a variable named test. And again, we'll range it, and we want it to start at 0 and end at 6 because we want 6 or 5 scores. So I think what I should do here is, instead of asking for this beforehand, I'm just going to make this a print statement. Print, enter 5 test scores for student, and then their student number. So I only need 2 closing parentheses. And then that way we won't ask for another prompt. We'll just keep reading in scores. Now, when we get a test, we want to append it to our scores array. So I think we need to know which student we're appending to. So we're going to try this. We're going to say, append a score for this student number in our scores array. Now let's print out our scores array when we get done and see if that works or does not work. We're right here at the end of our time, so we can see how close we are. Does it like that way better? It almost looked like from that example it wants the square brackets within square brackets. Okay, so I'm going to try this. I'm getting a good prompt. saying enter 5 test scores for student number 1. I'll do 10, 10. I got too many. I need to change that loop range, and then I'll keep entering. Oh, finally it crashed. So it worked for the first one, but it didn't work for the second one. So every time we get a new student, do we need to add to the size of our array? So I need to do scores dot append for our student. So let's see, I want to change this inner range to be 0, 5, because I was entering 1 too many. Weirdo character got up there from my typing. So now I'll try again. 10, 10, 10, 10, 10, 20. Nope, still crashed. Doesn't like that second one. So we're gonna have to do some debugging. So you are welcome to try some debugging, but when we're using 2-dimensional arrays, you're gonna see a lot of interesting syntax out there for it. So let's see if we can figure this one out and report back next time. Now, next time we'll fix this and get all of our collab document turned in. So do not worry about getting it turned in today. Today you do need to get your review questions for chapter 7 done, but this one will not be due today. We'll figure out what's going on with our 2-dimensional array, just so that you have an example of it working. And then we'll start with our file access. I'll show you a real quick image glitch. It's really fun. So here's what we'll be doing with our image glitches. Some of these get pretty intense. It's kind of a really cool new art form. And I had a student do a presentation about it a couple of years ago. And so I looked into it to make it an assignment for us. And I really liked it. And I think most of the students do. So what glitching in images is taking an existing image and changing some of the pixels or rearranging. So we can get like, some of these that are screenshots are really cool. There's one. The matrixy one, of course, I like. There's one, oh, this one is really good because if you've ever had a hard drive fail and you've spent hours watching that low-level diagnostics run to see how many of your sectors are bad, which unfortunately I have spent weekends of my life doing that before, then that one is really cool because that's what this is the hard drive low-level formatting display, and they've glitched it onto another image of a person there that's also been glitched out a little bit. And some of the ones that are really cool that are kind of hard to figure out programmatically, like this one, it's just a slide, right? They were just taking the pixels, the XY coordinate, and kind of shifted some of them over to give it this kind of cool effect. But it can take a lot to do that programmatically. This one here is like the same image kind of glitched and overlaid on top of itself to give it some special effects. So we'll be doing some pretty simple glitches ourselves. We're like this one where we might make some black lines through some parts of our image or do some different things like that. But I want to show you how to do it because it's neat because we'll be accessing that image as a 2-dimensional array, going through for all of the pixels and changing things. So that's what we'll be working towards next time. So we'll fix this one. Try to debug this program for us so that we know what to do with it next time. And I'll try to too. So I get it. Yay, check marks, everybody's ready. You guys have a great day. I will see you Wednesday. Everybody okay at home? Pass, John. I love all the check marks.
I'm in your C# class next semester.
Oh, good.